Welcome to Pradip sir classes as PSC where logo can talk the physics students, and we are in the numerical king series AC Verma chapter 29 question number 48, and obviously it is electric field and potential. So students, if you are first in that class, then go back to the previous one where I solved up to 47 numericals from chapter 29, and also for the particular chapter there is 30 Gauss law, all the numericals. There is one from 24 are completed, and the chapter 1 it is also completed. Okay, and you can also follow a different text series. There is a text series, Erode solution, Erode solution. Okay, so let's start with question number 48. First of all, student, write down the question and again pause the video, then if it is possible then see the answer. Okay, so 48, a particle of mass 1 gram and a charge this is released from rest in an electric field. Okay, so there is an electric field. This is the electric field. A electric field is given here and its value is also given. So electric field is 1.2 into 10 to the 4, 1.2 into 10 to the power of 4 Newton by Coulomb electric field, and the charge Q equal to 2.5 into 10 to the minus 4 Coulomb, 2.5 into 10 to the power minus 4 Coulomb is released, and its mass is also given. So this is, there is an mg, and here m is given 1 gram equal to 10 to the power minus 3 kg. Okay, gram is given. Find the electric force and the force of gravity acting on this particle. Can one of these forces be neglected in comparison with the other for approximate analysis? Okay, so the electric force, if a charge is released at a particular point within the electric field, there is an electric field along this direction, students. So this electric field can exert an electrical influence on that particular charge along this direction, and you know that this is F equals to QE. So the electrostatic force, and it is Q means 2.5 into 10 to the power minus 4 into electric field, that is 1.2 into 10 to the power of 4, and 4 cancel this one, 5 12 just 60, there is 6 and 24, and this is 30 and 0.3, so 3. So 3 Newton force act. Again I explained, there is an electric field along this direction, there is an electric field along this direction of magnitude this amount. If a charge is released at a particular point, then this charge can experience an electrical influence, that is electric force along the direction of electric field. एक चार्ज पार्टिकल है, मतलब चार्ज पार्टिकल इलेक्ट्रिक फील्ड में है, तब क्या होगा? Along this direction, this charge can experience a force, obviously, and this force is of 3 Newton. Okay, as well as the particle, the charge particle can experience a gravitational force. Obviously, there is a mass, the mass of these chalks, and if we release the chalk, then the chalk falls along this direction, because the charge particle also experienced a force along this direction, but this is very small, and the gravitational force is m into g, that is 10 to the power minus 3 into g means 9.8. so this is Newton, and this is 3 Newton, and this is suppose if I take this is 1, then 1 by 1000, and this is approximate value of this. If I take this is 10, then this is 1 by 100 Newton force act along this direction, and this is very negligible with respect to this one. So this force acts along this direction, and the charge particle move along this direction, and we can take approximate calculations for that particular one by neglecting this one. So the charge particle obviously move along this direction. Okay, so a charge particle is kept within the electric field, but the force along this direction is 3 Newton, but along this direction a small force, that is 1 by 100 Newton. This is very much negligible with respect to this one, so we consider the charge particle moves along this direction. Okay, so the next one is, yes, we can neglect this one. And how long will it take for the particle to travel a distance of 40 centimeter? So what is the, you have to calculate how long will it take. So the time taken by the particle to cover a distance of, so time taken to distance covered, initially it is 0, so u equal to half a t square, and since this is 0, and then half a t square, or you can take as t square equal to 2s by a, or t equal to root over of 2s by a, and the distance s is, so 2 into s is 40 centimeters, so this is by 100, and the acceleration is equal to force equal to 3 Newton, and the mass is given, so mass into acceleration equal to 3, or acceleration equal to 3 by mass, that is 1 gram, that is 10 to the power of minus 3, so this is 10 to the power of 3 meter by second square, obviously. So 3 into 10 to the power 3 is the acceleration, so 3 into 10 to the power of 3, so this is 80 by 3 into 10 to the power of 3 and 2, so this is 10 to the power of 5, and 8 by 3 into 10 to the power of 8 by 3 into 10 to the power of minus 4. Since this is 5 and this is 10, so 1, 0 and 0 cancel, and this is 10 to the power minus 4. So this is 3 to just 6, 3 to just 6, and 6, 7, and 10 to the power of minus 4. So this is root over of this one. Okay, so root over of this one, and root over of this one, so root over of this one, and it is equal to, approximate, the result is, and you can calculate it with the help of calculator. Okay, so 48, and the answer is 1.63. It is 1.63 into 10 to the power of minus 2. Obviously minus 2 seconds, minus 10 to the power minus 4 minus 2, and if you take a root over of this, then you get this one. So 1.63 into 10 to the power minus 2 second the charge particle take to move along the direction of electric field of 40 centimeters. Okay, and the next one is, after discovering this particular, since it is an acceleration, so this is the charge particle you think, and it is released within the electric field, so it moves along this direction and it accelerates. After covering the distance of 40 centimeter, it reach a particular speed. What is the speed of this? So v equal to u plus at. So v equal to u plus at, and acceleration is also given, and the time is this one, so you can calculate, this is a into t, or acceleration is 3 into 10 to the 3, so 3 into 10 to the power of 3 into time 1.63 into 10 to the power of minus 2 second, and this is meter per second. So this is the final answer. So the final answer is 40, question number 48, and this is 48 is 49 meter per second. Oh, sorry, this is 49 meter per second. You can calculate also. 3 3 is 9, 3 6 8 approximate 3.9. Okay, 49 meter per second. Okay, and the last one is, and the last part of this numerical is, and how much is the work done by the electron electric force on the particle during this period. Okay, so work done equal to force into displacement. So force is also given, force is 3 Newton, force, work done equal to force into displacement, that is 40 by 100. This is cancelled, so 12 by 10, or 1.2 joule. So 1.2 joule is the answer, I think. Yes, it is 1.20 joule of energy is required to move the particular electron from this position to 40 centimeter. Okay, so thank you students to watching for this video and obviously connecting with me and watch the channel. So thank you.